Okay, well, let's start with your questions then. We can add to this list if we need to. The first one, you guys all, number one, you guys remember how to write the equations of them. You do the first derivative, plug in your x, that gives you the slope, and then you have your point and your slope, so you guys can write your equations. I'm trying to look through, kind of glance through real quick. On number 2, did you guys all reduce an x before you tried to do that derivative? Otherwise, you would have to, within your quotient rule, do a product rule as well. It will reduce at the end, but it gets a little ugly. All right, so 14. Differentiate, that means find the derivative. How did you guys rewrite the problem? There are a couple, probably 3 to 4 different options. What did you do? The whole thing to the 1/2? Yeah. Okay. So you can write it like this. You could take the 1/2 to the top and bottom separately. Some of you like to rewrite your quotients as products, and so you could do t squared minus 1 to the 1/2 times t squared plus 1 to the negative 1/2. Do product rule, so lots of different options there. So the way we have it written, we are going to do our chain rule. Make sure when you do your derivative you are labeling, so it's f prime now. Exponent comes down, inside stays the same, subtract 1 from the power, so now it's a negative 1/2, times derivative of the inside. How do I do the derivative of this inside? Quotient rule. So low, d high, derivative of the top will be 2t, minus high, d low, derivative of the bottom would also be 2t, over low squared. Now, I haven't been requiring you to go to any great lengths to simplify these, but if you just left it as this, I would deduct some points. There are several things you need to do to start simplifying here. At the very least, let's focus on that second piece for a moment. I do expect, this is just a single term, I think you can multiply that out fairly easily, so I would like for you to do that. So if I distribute my 2t, that's 2t cubed plus 2t. This one I need to distribute a negative in my 2t. So minus 2t cubed plus 2t. So if you didn't go this far, start adding this in, please. I am going to rewrite this actually, no, I'll do that in a second. Here the 2t's cancel out, or the 2t cubes cancel, so 2t plus 2t is 4t. Over t squared plus 1 squared. Okay, we're close. Couple more things. If you have a 4t and a 1/2, what would that simplify to? A 2t. Okay, let's combine these into one big fraction. If this is a negative exponent, where would it go? The bottom. Okay, I'm going to go ahead and multiply these together because they're the same term, so you just add your exponents. Negative 1/2 plus 2 is positive 3. And so that is our final answer. So regardless of how you simplified, you would have gotten to that point. Are you okay on 14? So it's 16. When you have cosine squared x, that means you're going to take cosine of x and square it. And that's like a sine of x cubed. So that's what those exponents mean. What do we have to do here? Product rule. So derivative of the first, looking at this first piece, to do its derivative, the 2 comes down, inside stays the same. You subtract 1 from your power, now it's just the first, times the derivative of the inside, derivative of cosine, negative sine. Now that's just the derivative of the first piece. We still have times the second one. Plus the first times the derivative of the second. So the derivative of this, the 3 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. Cosine. So you do have to watch when you're doing multiple rules at a time. Okay, again, if you just left it as this, I would take off because you're not simplifying enough. I expect you to pull coefficients out in the front. Since this is a negative sign, I'm going to write a -2 in front. I have a cosine. If I have a sine times sine cubed, that would make sine to the 4th. Second term, I could pull the 3 to the front. I have a cosine squared and a cosine, so that's cosine cubed and a sine squared. Do you guys understand how I'm doing this? Yes.
Can we like view it with the parentheses?
Other questions on that? So you guys were good, 17 and 18? No issues with that either? Let's look at 19. Find dx dt. So find the derivative. Okay, so we have to do a quotient rule. So low, so that's tangent 5t. D high, so derivative of the top. Derivative of secant is and we keep the 3t. Then we have to do the chain rule there. The derivative of 3t is 3. So there's low d high minus high d low. Derivative of tangent, secant squared, and the derivative of 5t is 5. All over low squared. Okay, as far as what I expect you to do to simplify this, coefficients need to come out in front, so pull the 3 out. Can I multiply these tangents together and make it a tangent square? No, because the angles are different. This one, pull the 5 out in front. Does anything reduce here? These terms both have a tangent 5t, but this one does not, so we can't cancel it. If you were really ambitious, you could change your things to sines and cosines and get some pieces to drop out, but it's really not going to make it much better, so I'm probably going to leave it like this. Is that one okay? Problem 20. These are the ones on like homework and quizzes. You guys have bombed these questions because you try to do them as a product. This is not saying secant times cosine, because notice I don't have like secant of t times cosine of t. This is secant of cosine. So we are doing chain rule here. Chain rule, you start where? On the outside. So derivative of the outside. Derivative of secant is, and the inside stays the same. So it's secant cosine 3t times tangent cosine 3t. So secant tangent times derivative of the inside. Derivative of cosine, negative sine. The angle would stay the same, but we're still not down to a plane t, so times the derivative of the angle is 3. So then we can pull this 3 and the negative out in front. Any questions on that? Do you guys see the difference between when you have to do the product and the chain rule? Problem 21. Okay, so we have f of x equals f of f of x. All right. If I ask you to do this derivative, you start on the outside, correct? So we would have to start with this one right here. So we're doing chain rule. Chain rule says derivative of the outside. So without the function, all I know is the derivative of f is f prime. Inside stays the same. But we're working our way in. So now we have to do times derivative of the inside. So the derivative of that one would be f prime. Its inside stays the same, which was f of x. Working our way in, this one would become f prime. Inside stays the same. Do we have to go another step? We're down to f of x. If you did the derivative of the inside this time, the derivative of x is just 1. So that's when you know you've gone as far as you can. Now, I asked you to find f prime of 1. So, these x's are really 1s now. Okay, let's start here. What is f of 1? 2. So that little inside part becomes a 2. Okay. Working our way out there. What is f of 2? So that's f prime of 3. And what is f prime of 3? 6. That's the first term. Okay, next one. F of 1 is 2. So we have f prime of 2, which is 5. This one, f prime of 1 is 'so if you multiply those, you get 120 for your final answer. Neatness is really important there, so you have some idea of what you're looking at. You also want to make sure on that type of question you are showing me some work, not just writing down a final answer, because that's definitely worth more than just 1 or 2 points on the test. And if you don't show me anything and you make a mistake, you're missing a lot of points.
Did we go over 22?
Yes. So we know that S is cosine of 2 pi t. All right, we are asked to find acceleration. What is acceleration? Second derivative. What is first derivative? Velocity. Okay, so our velocity here, the first derivative, you have to do chain rule, so derivative of the outside, derivative of cosine is negative sine, angle stays the same, times the derivative of the angle would be 2 pi. So we get a negative 2 pi sine of 2 pi t. Do I have to do the product rule to do the second derivative? Does this have a variable in it? No. So 2 pi is just a coefficient. So we don't have to do the product rule. So our acceleration second derivative coefficients just stay. What's the derivative of sine? Derivative of sine is cosine, angle stays the same, times derivative of the inside is 2 pi. So then if we multiply those, negative 2 pi times positive 2 pi, negative 4 pi squared. Okay. So from there, what do I have to do? Right, I asked for the acceleration after 5 seconds. So if I plug in my 5, two pi t times 5 would be at 10 pi. I know some people put this in their calculator, which is fine. Cosine of 10 pi is the same as 0, remember, because they're coterminal. And cosine of 0 is radical 4 over 2, so 1. So it's just negative 4 pi squared. Is that okay? Right. 23. Says the total cost of repaying a student loan an interest rate of R% per year if C equals F of R. What is the meaning of the statement F prime of 10 equals 1200? I can promise you, I will put something on your test that asks you about the meaning of a derivative. Okay, a derivative tells you a rate of change. We know the F of R is equal to C. R is your rate and C is your cost. So when I ask you for F prime of 10, what's the 10 represent? $10 is the R, and R is the rate. So let's say when the interest rate is 10%, so you have to use that number in there somewhere. Okay, now is this saying my cost is $1,200? No, it's how the cost is changing. So it is positive, so the cost is increasing by $1,200. We were measuring this, it was R% per year, so it'd be $1,200 per year. So, it does not tell me what the actual cost is. It just tells me what's happening to the cost. So, if we're at an interest rate of 10%, then I would expect the next year the cost to go up by $1,200. Okay. You guys were good with 24, so 25. The definition of a derivative. This will be on there. Probably not multiple questions, but you can expect one or two, and they're going to be worth several points. Now the good side is, now you know all the rules, so you could quickly go out to the side and do a quotient rule here and know what your answer should be, so you'll know if you get it right. But you need to be able to do it the old way, because eventually, sometimes there are functions that we can't just apply our product and quotient rules to. That's where this method still comes back into play. So the definition, we had several different forms. The one we preferred was limit h approaches 0. F of x plus h, if you did f of a plus h, that's fine, minus f of x all over h. You need to know this. That is the definition of a derivative. So, we've got the limit as h approaches 0, f of x plus h says go to your function, plug in an x plus h for your x. Minus f of x all over h. All right, what do I need to do next? Common denominator. So we're going to take the first one times the 3 plus 2x on top and bottom. And we're going to take the second one times the 3 plus, can I write it as 2x plus 2h if I just distribute that through. So one big common denominator there. So the first one, if we distribute that out, we get 12 plus 8x over the denominator minus, if I distribute my 4, over my denominator, denominators are the same, so we can combine those into one big one. Make sure though, when you do that, you need to distribute this negative. So then the 12s would drop out, the 8x's would drop out. And we have a negative 8h over this denominator. And I'm going to rewrite this, instead of one big fraction, that's like an h over 1, so you could flip and multiply by 1 over h. So then what could we do? Right. Drop that h out. Now we can plug in our 0. The reason we couldn't before is because we got a 0 on the bottom, but we no longer have that issue. So we have a 3 plus 2x. This one would be a 3 plus 2x plus 0. So you get negative 8 over 3 plus 2x squared. So that's the definition, which you should be prepared to do. All right. What else do we need to go over?
18.
18. I would rewrite this as the cosecant of t to the negative 3 power, just so you don't have to do a quotient rule within that. So then, our dx dt, we're going to do the chain rule. So derivative of the outside. Make sure you're studying your derivatives of your trig functions if you've forgotten them. So derivative of cosecant. Remember, all the cos have a negative derivative. So what's this one give you? Negative cosecant, cotangent. The angle stays the same. Times derivative of the inside. Derivative of t to the negative 3 would be negative 3 t to the negative 4. Simplification here, I would ask for you to please move that to the front, and then you have two negatives, which make it a positive 3t to the negative 4. And that would be our final answer. What else?
Which one is like the sine theta over theta?
Oh, you're talking about the limit ones.
Yeah.
Yes, okay. Sorry, it took me a second. Hold on, I don't want to make it one of those. All right, so if I asked you to do the limit as, you want an easy one or a hard one? Okay. So from here, remember if it's sine theta over theta, if we're doing the limit as theta approaches 0, sine theta over theta, then it turns into a 1. Now if your angle is something different, if it's like a 2t, then it has to be sine 2t over 2t, or flipped. We can't plug in until you no longer get 0 on the bottom. So let's kind of separate this a bit. I'm going to leave the sign here for a minute. How do you rewrite tangent? Okay, so this would be a sine 6t over cosine 6t. And I'm going to go one step further. I'm going to pull those apart. Just so we can kind of make it a little more obvious. Now, in order for this one to work, what do we need on top? A 2 and a t. Okay, if I'm going to put them on the top, I have to put them on the bottom somewhere as well. Do I need the 2 anywhere? No, so I'm just going to throw it on the bottom over here. Do I need the t on the bottom anywhere? Yeah, I need it on this one, so I'm going to put the t on that one. As long as it cancels, as long as it's on top and bottom, it's legal. Since they're multiplied, you can. If they're added, you can. Okay. This one is a 6t, so I need a 6t on the bottom. I already have the t, but I need a 6. Now if I put a 6 on the bottom, we have to put a 6 on the top. So, now if we evaluate, the limit as t approaches 0 of 2t over sine 2t, that would go to 1. Sine 6t over 6t would go to 1. I have 6 over 2 times, what's the cosine of 0? Radical 4 over 2, so 1. So I get 6 over 2, which is 3. Anything else specific that you guys want to talk about? Okay, let me give you a problem. That's something that's going to work out nice. This is trouble. How about okay. Okay, take a second to do that. So this is like 3t plus 3 to the 1/2. So then your first derivative, the 1/2 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside would be 3. So that's a 3 over 2 times 3t plus 3 to the negative 1/2. But I want the second derivative. So the negative 1/2 comes down. So you get 3/2 times the negative 1/2. Inside stays the same. Subtract 1 from the power. Negative 1/2 minus 1 times derivative of the inside. So then if you're multiplying your coefficients, 3/2 times negative 1/2 times 3 gives you negative 9 over 4. Now what do I need to do? Plug in a 2. Okay, so I've got negative 9/4. If I were going to do this without a calculator, a negative exponent puts it on the bottom, right? A 3/2 power is meaning the square root of this cubed. So that would give me the square root of 6 plus 3, so square root of 9 is 3 cubed. Thank you. So that would give us 4 times 27. Can I reduce to 9? If I'm doing this without a calculator. Because 9 over 27 reduces to 1/3 times my 4. Are there questions on that one? Yes, you can. Because it was a 3/2. All right, B, what do we have to do? Quotient rule. So low, D high. What's the derivative of e to the 3x? E to the 3x times 3, because we have to do the chain rule, minus high d low, so 4x cubed, over something you guys have struggled with. When it's this squared, what do you do with those exponents? Multiply. What can you reduce here? I can cancel out 3 of the x's, so you get 3x e to the 3x minus 4e to the 3x over x to the 4th. Yes, ma'am. Yeah, if you made it a negative 4, yes. All right. Any questions there? I think I'm about out of time, so I'm probably going to stop here. Make sure you know the definition of a derivative and your derivatives of the 6 trig functions. If you don't know those 6 derivatives, it will add up in a hurry. So study those. Let me know if you have any questions. Test tomorrow.